These are notes from section 6.6 on function operations. There are 5 function operations that you'll learn here in this section. 4 of them you're already very familiar with, or you should be. The first is function addition. As you could guess, we have subtraction, multiplication, and division as well. One thing that might be a little bit new is this notation right here. F plus g of x. Again, that's read f plus g of x. That's the same thing as just adding f of x and g of x. F of x plus g of x. Same thing if we're subtracting. F minus g of x is the same as f of x minus g of x. If we're multiplying, f times g of x, we're just going to take f of x and multiply it times g of x. Or if we divide, we will take f of x and divide by g of x. So all of these you're very familiar with. Last chapter, we talked about adding or subtracting or multiplying polynomials. We've been adding, subtracting, multiplying, even dividing radical expressions in this chapter. We had both long and synthetic division if we were dividing polynomials. So there's lots of ways that we can evaluate those things. So one quick example here, we'll call it example 1. That's an L. Example 1 says let f of x equal 3x minus 2 and g of x equal x squared minus 1. Part A asks us to evaluate f plus g of 5. F plus g of 5. So this notation where it says f plus g of 5, I think it's usually easier to think about the other way that I wrote these, the way on the right here. So I'm always going to rewrite it in these terms anytime it's given to me in these. So f plus g of 5, that's the same thing as f of 5 plus g of 5. F of 5, we've evaluated functions like that lots of times. That means go to f of x and plug in 5 for the x. So that would give me 15 minus 2, which is 13. G of 5 means go to g of x and replace the x with 5. 25 minus 1 is 24. And adding 13 and 24, f plus g of 5 is equal to 37. We could do the same thing if that's minus or times or even divided by. Part B, we are also asked to evaluate, same directions, but this time it is f times g of x. F times g of x. So in part A, we were given a specific x value to plug in. Here we are just asked to multiply f of x and g of x. Remember, f times g of x is the same thing as f of x times g of x. Well, f of x is equal to 3x minus 2. And g of x is equal to x squared minus 1. And I have a binomial times a binomial, so we should be able to FOIL and expand here. So I've got 3x cubed minus 2x squared minus 3x plus 2. Easy enough. Nothing new, nothing really major outside of this notation written like that. So those are 4 of the 5 function operations that the book discusses in section 6.6. The 5th one is new. It's called function composition, or a composite function. A composite function is, it's a function within a function. So what we're going to do is we are going to take the output from one function, whatever we get out of one function, we're going to put that into another function. The output of one function becomes the input of a second function. The way function composition looks, the notation that we use, it's again written two different ways. The first way is we have f, and we use a little open circle there, g of x. This is read f of g of x. Does look like it says fog of x. This is an open circle in between the two. Again, there's a kind of an easier way to look at it, I think, and that is f of g of x, written like this. So we are going to take g of x, and we are plugging g of x into f of x. So continuing with example 1, it's the same f of x and g of x we had before. F of x is equal to 3x minus 2. G of x is equal to x squared minus 1. Part C asks us to evaluate f of g of 3. F of g of 3. First of all, open circle means function composition. If that's a closed circle, just that dot, that's multiplication. So this one is function composition. F of g of 3 written like that. Again, I would always rewrite it. It is easier for me to understand if it's written like this. F of g of 3. Those two things mean exactly the same thing. We're going to start all the way inside the parentheses. We're just going to look at this g of 3 right here. G of 3 we should be able to evaluate. We just go to g of x and we plug 3 in for the x. 3 squared is 9, minus 1 gives me 8. So I am replacing g of 3 with what it's equal to. It's equal to 8. Now it asks us to evaluate f of 8. F of 8 means go to f of x, plug in 8 for your x. 24 minus 2 gives us 22. Part D, let's evaluate g of f of 3. We did f of g of 3. Now we're just switching the order around. G of f of 3. Again, I would prefer to rewrite it like this. G of f of 3. F of 3. We're plugging 3 into f of x. 3 times 3 is 9. Minus 2 gives me 7. Now we're evaluating g of 7. G of 7 would be 49 minus 1. Notice the order that I do the operations in does matter. Some functions, it does not, like addition. 3 plus 2 and 2 plus 3 are the same thing. So addition is commutative, as is multiplication. Subtraction, division, and now function composition, none of those are commutative. Part E, just like before, sometimes we are given a number here, but sometimes we're just asked to evaluate f of g of x. Just like the other ones, I'm going to rewrite it in this form, f of g of x. I'm going to replace g of x with what it's equal to. G of x is equal to x squared minus 1. So instead of g of x, I am putting in x squared minus 1, where that g of x goes. Way up here, when we evaluated f of 3, We went to f of x and we replaced the x with a 3. So if I'm evaluating f of x squared minus 1, I'm going to f of x, 3x minus 2, and instead of x, I'm putting in this x squared minus 1. So I've got 3x minus 2, but I'm putting x squared minus 1 in for the x. And then we can distribute and combine like terms. 3x squared minus 5. Part F, let's do g of f of x, g of f of x. So if they had given it to me in this form, I would rewrite it. I gave it to you already in the rewritten form, g of f of x. Sometimes it's written like that, sometimes it's written like this. Start by replacing f of x with what f of x is equal to. F of x is equal to 3x minus 2. G of 3x minus 2 means go to your g of x and replace x with 3x minus 2. So I have x squared minus 1, but instead of x, I'm putting in 3x minus 2. We do want to simplify. Let's go ahead and write in standard form. You can either write 3x minus 2 out twice and FOIL it. 3x minus 2 times 3x minus 2 and FOIL. Or you can remember the rule when squaring a binomial. It's the first one squared. Multiply the terms together. So negative 2 times 3x is negative 6x, but double it, negative 12x. And square the last term, plus 4. Foiling would give you the same thing here. Combine up your like terms, I get 9x squared minus 12x plus 3. So most of the time, more often than not, they give us the equations for f of x and g of x. Sometimes instead of the equations, they give us a graph of f of x and g of x. So let's take a look at how we would take care of one like this. So example 2 asks us to evaluate, and we are given, instead of a equation for f of x and g of x, we're given this graph here. So they give us a graph of f of x and a graph of g of x. Part A, we are asked to evaluate f of g of negative 1. F of g of negative 1. First thing we're going to do is rewrite this in this other form. Again, I always think this is easier to look at. G of negative 1 means when x is negative 1, I want to know what g of x is equal to. So when x is negative 1, g of x, which is this function here, g of x has a y value of 0. G of negative 1 is 0. I'm just going to bring down my f here. So now we are evaluating f of 0. When x is 0, f of x has a y value of 3. F of g of negative 1 is 3. Let's do g of f of 0. G of f of 0. F of 0, we actually just said was 3. When x is 0, f of x is 3. So I need to evaluate g of 3. G of 3, g of x is right here, which is negative 2. You try these last two, get g of f of g of 3, as well as, let's do f minus g of negative 2. So pause the video, you try those two, we'll go over answers, and that'll be it for the notes. For part C, f of g of 3, we need to start with g of 3. When x is 3, g of x is negative 2. So we need to evaluate f of negative 2. When x is negative 2, f of x is 5. And part D, f minus g of negative 2, I would do f of negative 2 minus g of negative 2. F of negative 2 is 5. G of negative 2 is negative 1. I guess 6. That is section 6.6 on function composition. Reach out if you're having questions on anything.